Imagine taking a mind that operates 500 years in the future and providing it the tools of the 19th century Industrial Revolution. Erase the sun-drenched vineyards of the Renaissance and place Leonardo da Vinci squarely beneath the soot and smog of a Victorian skyline. During his actual lifetime, he faced a persistent barrier: friction and fatigue. Every mechanism he sketched relied entirely on human muscle, beasts of burden, or the unpredictable flow of a river. His famous armored vehicle is a prime example. On paper, it is a sophisticated predecessor to modern heavy cavalry. But beneath that wooden shell, the physics fail. 4 soldiers turning hand cranks simply cannot generate the torque needed to push a multi-ton fortress. Moving his birth forward by 4 centuries eliminates that biological bottleneck. His notebooks contain sound blueprints that lacked a capable engine to drive them. In an industrial timeline, the physical tools finally match the theory. Steam provides that missing engine. A coal-fired boiler delivers continuous, heavy-duty mechanical output that never tires. By swapping the wooden shell for heavy steel plating and replacing the human cranks with a pressurized steam piston, Leonardo's design becomes history's first functional, self-propelled armored vehicle. His work extends far beyond military applications. His notebooks hold precise designs for automated water pumps, complex hydraulics, and mechanical weaving systems. Hooking those intricate Renaissance blueprints to a central factory driveshaft turns theoretical mechanics into roaring automated textile looms. This scales rapidly. Precision water systems become urban plumbing networks, and hand-cranked workshops evolve into continuous assembly lines. The transition to a mechanized world accelerates, allowing for a shift toward industrial automation earlier than the historical timeline allowed. Steam power elevates his work beyond simple military hardware, allowing him to act as a primary architect of mass production by successfully engineering human muscle out of the process. Yet, his ultimate obsession always sat far above the factory floor. He spent years dissecting bird wings and sketching intricate gliders, determined to achieve human flight. His most ambitious attempt at vertical flight is the aerial screw, the conceptual ancestor of the modern helicopter. Once again, flesh and blood fail him. Human arms cannot spin a heavy wooden mast fast enough to catch the air and generate sustained lift. The late 19th century answers this problem with lightweight aluminum framing and early internal combustion engines, replacing heavy wood and porous canvas. Looking at the numbers in this schematic, replacing the human operator with a high RPM combustion engine flips the power-to-weight ratio. The central rotor finally spins at the velocity required to pull the machine straight up. In our timeline, it took until 1903 for a fragile biplane to barely clear the sands of Kitty Hawk. Armed with refined fuel and metal alloys, Da Vinci's aviation concepts mature rapidly. The sky becomes a viable route for global transport, generations before the modern airplane takes shape. His engineering successes provide a natural foundation for his studies of the natural world. To him, empirical research and delicate artistry were the exact same pursuit. His pioneering studies into how light bends through glass lenses find an ideal testing ground in a century of rapid industrial advancement. Combining his understanding of optics with Victorian industrial chemistry creates the exact formula for early, precise photography. He directed that same precision toward anatomy, treating the biological body as the ultimate, highly complex machine. He mapped shoulders and spines as mechanical systems, bones acting as rigid levers, and muscles pulling like tensioned cables. Wiring that structural understanding into an array of small steam valves and early electrical circuits yields remarkably lifelike automata, machines capable of mimicking fluid human motion. For Leonardo, the Industrial Revolution provides the materials to replicate life itself, uniting raw engineering with biological artistry. Stepping back from this timeline of steam-powered skylines and soaring metal rotors reveals a simple truth about his historical placement. The modern world arrives ahead of schedule simply because the manufacturing base finally matches his grasp of theoretical physics. His most enduring work exists as a methodology rather than a machine. That legacy is a specific way of thinking. He looked at a human limb, a flowing river, and a spinning gear, and understood they were all governed by the exact same natural laws. That interdisciplinary observation broke down the boundaries between biology and engineering. It pushed humanity to imagine the impossible, setting a standard for innovation that outlasts any single era. If Leonardo had possessed the power of steam and the strength of steel, which of his inventions do you think would have changed history the most?